Please welcome Bente, Knoll and Ralf Dopheide.
So many thanks for having us here. We are happy that we have the opportunity to have our presentation together. I will start and want to give you a short introduction about our topic. Let us take you to a journey into the green sector, into the real green within the building sector. We want to focus on plants. So we want to focus on, let's say, the living green that is very necessary for the future of our towns, buildings, and for the times to come. So let me start with explaining our title. Our project and our topic, our talk is about green BIM. So let me ask the question, what the heck is BIM, Building Information Modeling? We want to focus on landscape planning, landscape architecture, and also the greening components and greening communities. And when we look at the definition, BIM, Building Information Modeling, is a method that's very important. Building Information Modeling is not a software, it's a method for creation and managing data that is necessary to describe physical and functional information about a building or a building element. And with the help of BIM, it's possible to develop model-based model databases that include all relevant information, and therefore, under the responsibility of Building Smart International, the so-called IFC standard has been developed and is currently further developed in order to have a standardized format for data exchange. So in a broad view, BIM allows that all relevant companies, planners within the life cycle of a project and also of a building work together, exchange the relevant information. As I've mentioned, BIM is a method and is not a software, so that's really important. We use the IFC standard to exchange between different software programs and software solutions. Let me now take you a little bit into landscape planning. We start with just an overview how the planning scene has developed in the recent years. When we look back some decades ago, it was quite common only to draw in a 2D plan and to have all the information only on a piece of paper. With the help of software products and developments, and also with the help of building information modeling, it becomes now the standard that planners also use 3D models. As for the landscape planning, we are now really at the starting point. When we look at construction, architecture, or civil engineering, these fields and these disciplines are much further beyond. And with the 3D model, with the BIM model, it's also possible, as I mentioned before, to include relevant information, not only about geometry, but also other additional information about a building, about a component of a building, about an element of a building. So we have to deal with lots more of information than we are used some decades ago. And that, for sure, has also an impact on the companies, on the enterprises. And may I introduce to our international audience a little bit the world of landscape architects and landscape planners here in Austria. Here in Austria, when we look at the specific field of landscape planning, landscape architects, that sector consists of different enterprises, companies. We are happy that we have lots of companies and enterprises, but these enterprises are really very small enterprises with employees from 1 to 10. So we really have small entities, small companies, and you can imagine that digital shift that going into that building information world is quite hard for small enterprises. The small enterprises and companies, they have to invest into hardware, software, licenses, and you can imagine that that is really has an economic impact. And on the other hand, we have to have a look, when we look at transition, it's not only about, well, technical issues, it's also about human issues, social issues, and it's also a need for the people working in landscape planning companies that they build up their knowledge, that they gain knowledge, also about process development, and therefore it's really a big well, shift and a big challenge for the landscape companies here in Austria to well, also work with building information modeling. In an ideal world, I've brought you an image. In an ideal world, our best option is that building information modeling, that shifting and that information, not only geometrical information, but also other information, is available for all relevant companies, for all relevant people, institutions around the whole life cycle, and that that information is available over the whole life cycle, and it's not only including the planning phase, but also the maintenance and also, for instance, the renovation. So in an ideal world, the relevant information is available for the whole sector and the whole life cycle of a building or building elements. Well, that's an ideal world. Let's have a closer look how it is possible to, well, go step by step towards building BIM implementation. The BIM community has developed several levels on the step-to-step approach. BIM level 0 would be only working with 2D, whereas BIM level 3 would be that we have already reached the ideal world. Let me now take you to the landscape planning offices and the landscape architecture scene in a more closer look. When we look at landscape architecture, using building information modeling is not that common. When we look at the manufacturers, for instance, green roof systems and manufacturers who deliver green roof systems, there are only some building information objects available. And when we have a closer look, then we can see that relevant information concerning the plants and information that is needed to describe plants in detail are missing. When we look at BIM and using BIM in a 3D software, then landscape planners, landscape architects, they have to use geometric elements such as slab or column. There are no specific elements or that can be used by the landscape architect, so we have to use other elements from other disciplines. And when it comes to landscape planning projects, then it is the case that when we look at the cooperation between clients and landscape planners, mostly the clients, they define project-specific needs, just on the basis of the specific project, and the real standardization is still missing. That's where our research project, here you can see just a short information about how it looks in practice. So we have the building elements, and in that sense a tree illustrated in 3D model, and then the additional information is also included in the database beyond. And we face in landscape planning that, well, the standards are still missing, so that's why we started 2 research projects. The first research project, now I call it a little bit the pre-project, that's Green BIM 1. It was a project that was funded by the Austrian Research Agency, also with money from the ministry, and we could do the first research steps and had a close look on the status. And then at the end of the research project, we were happy that we had gained several results. So we focused, and that's important to understand that in the first project we really focused on greening that is directly associated to buildings. So green buildings, for instance, green roofs, green facades. So that was the main topic. And then we developed a proposal for an IFC standard that includes all the information that is needed for the plants that are related to a building. We also developed the suggestions for the Building Smart Data Dictionary, and also several use cases on a prototypical basis. And then at the end of the research project, we were happy that we had all the results. And then we thought, well, now it's really needed that these results really get into practice. That's why we are very happy that we could start with a second project, with a follow-up project last year in June. And we are very happy that now within that project we can carry out a practical proof of our results. Do these IFC standards and that proposal really work in practice? Is it possible that the landscape architects and gardeners really work with this information structure? And we are also working on further development of information that also includes horizontal landscape gardening and also open space planning. And we also have a strong focus in knowledge transfer here in Austria and at least in the German-speaking world. So, let me then also point out that we are happy that we have several learning modules for different target groups, and one is also a summer school for students. And we are very happy that our summer school is not in parallel with the summer school you have heard before. We will start in the first weeks of July, and our summer school will focus on green BIM for students in the field of architecture, landscape architecture. And whenever somebody is interested here in the audience, or also in the international audience on the screens and on your computers, please get in touch with us. And now I would like to hand over to my colleague Ralf, who will give you a short insight on the practical sides of our projects.
Yeah, very welcome. I would like to continue and present some insights. And as a gardener and a landscape planner, I want to give you a brief overview over all the themes Bente, Knoll presented. Global climate change affects everyone, especially residents of large cities through urban overheating. This urban overheating is increasingly counteracted by building greening because it provides shade, cooling, and a little bit more comfort. However, greening concepts are rarely included in BIM projects, and therefore I think it's necessary to support landscape architects and gardeners in participating in open BIM projects. We have identified building greening systems, attributes, and use cases. Following, they were implemented within the information management database BIMQ, it's called BIMQ. And after the implementation of the attributes to BIMQ, they were mapped to IFC and BSDD. BSDD, it's the Building Smart Data Dictionary. and they were structured, and so that they can be used as intended according to the use cases identified before. In the following slides, I would like to give you an overview of the components of building greening and criteria for integration in BIM. On the next slide, we will see the IKEA store in Vienna. There are large plant troughs with automatic irrigation on the roof areas, with drip hoses, for example, and equipment storage, pipes, irrigation, drainage, power lines are also needed for a perfect automatically irrigation. We have also considered substructures for wall-bounded greeneries, for example, or climbing systems for climbing plants, climbing aids for climbing plants. Let's move on to the next topic. It's plants as a living building material. As a living building material, plants have other properties than, let me say, than traditional building materials. We have location, exposure, needs like water and light, or maintenance, greenkeeping, and so on. There are many other properties we have to recognize. The proposed structure for the IFC model is shown here. It's for building greening. We have to require 3 greening systems, I like to say. Horizontal greening, it's mostly roof greening, horizontal, and vertical greening like facade greening and indoor greening. Yeah, indoor greenings can also be implemented both horizontally and also vertically, but only indoors. We have implemented 15 subsystems and approximately 270 attributes clustered in property sets. The results show that in future BIM projects with building greening, a specific domain model for building greening should be established. Only 23% of attributes necessary, mostly very general attributes, are possible to transfer with IFC. Relevant elements for building greening are generally missing in the IFC structure, and for specialists, this analysis is built on the older IFC standard 4.1 here. And this is how the structure looks like in BIM-Q and how it can be used by stakeholders of the construction industry or landscape architectures, for example. Here the right domain model, a building greening system can be chosen, and this property sets contain the attributes depending on the model, on the domain model, use case, and the project phases. The project phases on the right side there, and the use cases can be filtered here also. We identified 9 relevant BIM use cases in the life cycle of building greening. And to meet the information needs of these use cases, about 270 attributes are necessary, I mentioned before. Each attribute is available with information about project phase, responsibility, unit, IFC and BSDD mapping. Now I come to the BIM use cases. Use cases should make it easier to get started within the BIM method with an easier assessment of the effort involved and naming of those involved, or also it's necessary to know the necessary level of user knowledge in this field. Here it's a little bit too small to see, I think, but here operating processes are shown, use cases, the use case tendering and awarding of building greening. And here I would like to give you an example. At the top you have the BIM coordinator or clients, organizations, and so on. And in the middle, there is the planning and the planning disciplines, landscape architecture, static, and so on. And above, there is the facility management and, yeah, last but not least, the execution and the greenkeeping also. Mm-hmm. Here's a situation on the client side and the role in use cases. Here's the use cases are often defined in employers' information requirements in general and in BIM execution plans. And the following questions here need to be clarified, and it's also important what data is really needed and for what. Keep it mostly a little bit shorter, it's more practical. Mm-hmm. Now in the area of building greening, there are many interfaces, collaborations and coordinations, and a need for coordination across all project phases, such as planning, building, and operations. Based on this, use cases allow BIM applications to be organized into manageable units. This helps the implementation of BIM in your own company or in your organization, as well as a project level. And here, what should be the further consideration focused on use cases? What are your own most relevant use case in your company, in your organization? BIM use cases in planning in the area of landscape architecture are, for example, visualization, coordination, interfaces, quantity, and cost calculations. And I think we have to apply step by step in this field, try step by step, try it out and learn from it, from the use cases. My last slide, there are new opportunities through digitalizations and focused on gardening and landscaping. And just let me say, for me as a horticulture, landscaping, gardening company, digitalization was a challenge at first, but now the advantages outweigh the disadvantages. We have much more advantages now, and I think of the automated irrigation systems or the monitoring the condition of plant and soil, and I think this is very important for the future in gardening and landscaping, I think. We are, let me say, we are the whole day, we are participating the whole day at this conference, and please get in touch with us, and yeah, I thank you for your attention.
Thank you so much, Bente, Knoll, and Ralf Dopheide. Thank you very much for being with us today.